Okay, hello everyone. We are now on Module 9, which is all about pile foundation. But before we discuss the concept and principles of pile foundation, let us try to identify the learning outcomes for this chapter. So basically, at the end of this module, the students are expected to understand the guidelines and criteria for selection, design, and installation of pile foundation, identify testing procedures and load test method, learn the geotechnical analysis and design of pile foundations, learn the design and installation aspect of pile foundations, compute pile foundations related problems. So basically, pile foundations are deep foundations. Of course, we learned that we have identified that foundations can either be shallow or deep foundation. In our previous discussion, we focus on shallow foundation. When we talk about footing, either square footing, rectangular footing, trapezoidal footing, continuous or strict footing, those are considered for the construction of shallow foundation. However, there are cases that we need to resolve into deep foundations. So, pile foundation is a kind of deep foundation. It is actually a slender column of long cylinder made of materials such as concrete or steel, which are used to support the structure and transfer the load at desired depth either by end bearing or skin friction. So pile foundations are deep foundations. So pile foundations is a type of deep foundation which is generally used in high-rise building construction and bridge construction. It is also used where the site has a weak shallow bearing strata, making it necessary to transfer load to a deeper strata either by friction or end bearing principles. So pile foundation basically class is necessary to resist the uplift forces created due to water table rise or any other cause. These structures will need pile foundations. Pile foundation is necessary for areas where the structure surrounding has chances for soil erosion. This might not be resisted by shallow foundation. So basically, pile foundations is very costly. But despite of the cost, the use of pile foundation often necessary to ensure structural safety. So we have here conditions that require pile foundation. So what are those conditions that may require pile foundation? So the first one, when one or more upper soil layers are highly compressible and too weak to support the load transmitted by the superstructure, piles are used to transmit load underlying bedrock or a stronger soil layer. So this is an illustration for these are actually conditions that require the use of pile foundations. So for this one, when you have an upper soil that are highly compressible and too weak to support the load transmitted by the superstructure, so we try to use pile foundations, and basically the piles are used to transmit the load to underlying bedrock or a stronger soil layer. So this is the first condition. The second condition is when bedrock is not encountered. This is for letter B. When bedrock is not encountered at a reasonable depth below the ground surface, piles are used to transmit the structural load to the soil gradually. The resistance to the applied structural load is derived mainly from the frictional resistance developed at the soil pile interface. Then for letter C, this illustration implies when the subjected to horizontal forces. So when it is subjected to horizontal forces, pile foundation resists by bending. So while still supporting the vertical load transmitted by the superstructure. So this type of situation is generally encountered in the design and construction of earth retaining structures and foundations of tall structures that are subjected to high wind or to earthquake forces. This is the condition for letter C. For this one, in this case, there are many cases that we encounter expansive and collapsible soils. They might be present at the site at the proposed structure. So this soil may extend to a great depth below the ground surface. So expansive soil swells and shrink as their moisture content increases or decreases, and the pressure of the swelling can be considerable. If shallow foundations are used in such circumstances, the structure may suffer considerable damage. However, pile foundations may be considered as an alternative while piles are extended beyond the active zone, which is where swelling and shrinking occurs. So beyond, when talk about for this one, when you encounter a soil that has a swelling potential, so those are expansive soil that has a swelling or shrinkage potential depending on the moisture content, whether it increases or decreases. So if we try to use shallow foundation, it may result to damage. So we try to use a pile foundation as an alternative when piles are extended beyond the active zone where the swelling and shrinkage occur. So for letter A, this one is a foundation of some structures such as transmission towers, offshore platforms, and basement mats below the water table are subjected to uplifting forces. So piles are sometimes used for this condition to resist uplifting forces. So of course, that's one our retaining walls, for example, they are subjected to uplifting forces. So we try to use pile foundation to resist the uplifting forces. For this one, okay, this is bridge construction. So bridge abutments and piers are usually constructed over pile foundations to avoid the loss of bearing capacity that a shallow foundation may suffer because of soil erosion at the ground surface. So these are conditions that require the use of pile foundation. So basically, why do we have to make use of pile foundation? So if compressible, we use pile foundation for a compressible or weak upper soil layer, presence of horizontal forces, third, presence of expansive soil, fourth, subjected to uplifting forces, and five, soil erosion, because of soil erosion. So basically, for us to have a structural safety, so we resolve that one through the use of pile foundation. Although numerous investigations, both theoretical and experimental, have been conducted in the past to predict the behavior and the load-bearing capacity of piles in granular and inclusive soil, the mechanisms are not yet entirely understood and may never be. The design and analysis of pile foundations may thus be considered somewhat of an art as a result of the uncertainties involved in working with some subsoil conditions. So basically, we have different types of different types of piles, and they have their specific structural characteristics. So different types of piles are used in construction work. It is dependent on the type of the load that it will be carried, the subsoil condition, and the location of the water table. So piles can have different categories. It can either be steel piles, concrete piles, wooden or timber piles, and composite piles. So for steel piles, are generally either pipe piles or rolled steel each section piles. Pipe piles can be driven into the ground with their ends open or closed. Wide flange and I-section steel beams can still be used. So the allowable structural capacity of the pile is equivalent to this one. So that is equal to the area of the cross-sectional area of the steel pile, and multiplied to the allowable stress of steel. Allowable of steel is 0.33 to 0.5 of F sub Y. So the steel pile may be subject to corrosion. For example, Swamps and other organic soils are corrosive. Soils that have a pH greater than 7 are not so corrosive. So to offset the effect of erosion, an additional thickness of steel is generally recommended. So thickness, it can be over the actual design cross-sectional area. So in many circumstances, factory-applied epoxy coatings on piles work satisfactorily against corrosion. So these coatings are not easily damaged by pile driving. So the following are some general facts about the steel pile. So you have here the characteristic of steel pile. So we have here a table showing to us the common Hval section used in other countries. So we have the designation for the size and the weight, and you have the depthness, you have the cross-sectional area, flange and web thickness, you have the flange web moment of inertia. So we have here a selected pile section. So these are in SI units, this one is in English unit. We are given with the outside diameter, the wall thickness, and of course the area of the steel pile. So we have here showing to us, this is an illustration for steel piles. You have the splicing of Hval by welding, splicing of pile by welding. You have the splicing of Hval by rivets and bolts. You have the flat driving point of the pipe pile, and you have the conical driving point of the pipe pile for this one. So for concrete pile can be divided into two categories. So precast piles can be prepared by using ordinary reinforcement, and they can be square or octagonal in cross-section. Reinforcement is provided to enable the pile to resist the bending moment developed during pickup and transportation. So the vertical load and the bending moment caused by a lateral load. So that's one this is showing to us, this is an illustration for a precast pile with ordinary reinforcement. So we have a square pile and an octagonal pile. So for precast piles, this can also be pre-stressed by the use of high-strength steel pre-stressing cable. So for this one, the ultimate strength of the cable is approximately 260 KSI, or that is 1,800 meganewton per meter squared. During the casting of the pile, the cables are pre-tensioned to about 900 to 1,300 meganewton per meter squared. So after the curing, the cables are cut, producing a compressive force on the pile section. So we have here the general some of the characteristics for a precast pre-stressed piles. So we have here a table showing to us the typical pre-stressed concrete pile that is used. These are in SI units. Then we have the second one, type of concrete pile, the cast in situ or cast in place piles, which are built by making a hole in the ground and then filling it with concrete. So basically, you try to make a hole in the ground surface, then you try to fill it with concrete. So that is what we call cast in situ or cast in place concrete piles. So these case piles are made by driving a steel casing into the ground with the help of modular placed inside the casing. So for this one, the allowable load is equal to area of the cross-sectional area of the steel multiplied to allowable stress of steel plus the area of the concrete, cross-sectional area of the concrete multiplied to the allowable stress of the concrete. And we have here a table showing to us the typical pre-stressed concrete pile that is in English units. So we have here the cast in place concrete pile. So these are some of the types of cast in place concrete piles with its corresponding characteristics. So for uncased piles are made by first driving the casing to the desired depth and then filling it with a fresh concrete. The casing is gradually withdrawn. So for this one, the allowable load is equal to area of the cross-sectional area of the concrete multiplied to the allowable stress of the concrete. Then for timber piles, the maximum length of the timber piles is 10 to 20 meters. Its allowable carrying capacity is equal to average area of the cross section of the pile multiplied to allowable stress on the timber.